Now we start our next lecture. Lecture is about exercise 2.5 on page number 49. First of all, we review the definition of a real number. Then we come across the definition of a complex number. Then we solve the different questions in exercise 2.5 related to complex number. In a previous definitions, we study about real numbers or real set. Real numbers. Definition according to real number is a number whose square is always non-negative is called a real number. Any number, if we take a square of the number, the answer will be non-negative. Such number is called a real number. For example, if we take a square of 0, it becomes 0. Therefore, 0 is a real number. Now again, if we take a square of -1, it becomes non-negative number, that is 1. Therefore, -1 is a real number. Similarly, if I take a square of square root 2, it becomes 2. Therefore, square root 2 is a real number. Similarly, there are so many examples or numbers. If we take a square of the number, then the answer is always non-negative, are the real numbers. Now we come across the next definition, the very important definition of a complex number. What is a complex number? Next definition, a complex number. We study the theory about a complex numbers. First of all, here we define the complex number, a number which can be written in a plus iota b form. Any number which can be written in a plus iota b form, where a b belongs to real number. A and b belongs to real number. A number whose which can be written in a plus iota b form, where a b belongs to real number, is called a complex number. Is called a complex number. A number whose square, a number which can be written in a plus b form, is called a complex number. Complex number. In a complex number, we have two parts. One part is a real part and other part is a imaginary part. What is imaginary number? In a complex number, there are two parts. One part is a real part and other part is a imaginary part. The part which contain I, here we read I as iota. The part which contain I, here we read I as iota. Iota is a Greek symbol, a Greek word, is called a complex number. Such type of number is called a complex number. It is denoted by Z. Complex number can be denoted by a small symbol z. That is, a complex number z is equal to a plus iota b, where the condition is that Re of z. Re of z means real part of z is a, and Im of z. Im means imaginary part of z is b. The coefficient of iota is imaginary part and other part is the real part. Here we write real of z in short form Re of z means real part of z. Similarly, imaginary part of z, complex number, imaginary part of a complex number, which we write as Im of z, that is imaginary part of a complex number. Here we define the other number which is a complex number which can be written in a plus iota b form, where a and b both are real numbers. Complex number is denoted by a symbol z. Complex number is denoted by symbol z, and the complex number is written in the form z is equal to a plus iota b, where real part of z is a and imaginary part of z is b. And also note that also note that here iota is equal to square root minus 1. Iota is equal to square root minus 1. Here iota is equal to square root minus 1. Iota is imaginary number. It's imaginary and we read it as iota, and iota is equal to square root minus 1. In a previous definition, of a real number, we define a real number as a number whose square is always non-negative. If we take a square of a number and answer is always non-negative, here we see, if we take the square of 0, we get the answer 0, which is non-negative. If we take the square of negative 1, we get the answer positive 1, or non-negative answer, which is 1, is a real number. Similarly, square root 2 square is equal to non-negative number. Square root 2 is a real number. But in case of iota, if we take the square of iota, iota is equal to square root minus 1. If we take the square on both sides, after cancellation square with square root, we get negative number. That's why iota is not a real number. Iota is not a real number, because by definition of real number, if we take the square of a number, it becomes always non-negative. But in the case of iota, if we take the square on both sides of the value of iota, we get negative 1. That is, we cannot get the non-negative value. Therefore, iota is a complex number. Clear? Then next, conjugate of complex number. Here we study about the theory of a complex number. The next one definition is conjugate of a complex number. Let z is equal to a plus iota b be a complex number. Z is equal to iota b be a complex number. Then z bar is called conjugate of complex number z. Z bar is the conjugate of complex number z. How we calculate the conjugate of a complex number? As z is equal to a plus iota b. Then if we taking conjugate on both sides, that is conjugate of z is equal to a plus iota b conjugate. Here remember that conjugate of real number is itself. Conjugate of real number is itself. That is, conjugate of a number a is equal to a. Similarly, conjugate of a number b is equal to b. But conjugate of imaginary number, change the sign of the number. In a conjugate of imaginary number, change the sign of number. That is, if we take the conjugate of iota, we change the sign of iota. If iota is positive, then we change the sign into negative. If iota is negative, then we change the sign into positive. Then this z conjugate becomes a minus iota b. If there is a positive sign in between the numbers, then we change it into a negative sign. If there is a negative sign, then we change it into a positive sign. Or in other words, we change the sign of the value which contain iota. We change the sign of value which contain iota. We have example. For example, here we take an example. For example, let we have a different complex number. The first complex number we called it z1. Z1 is equal to 2 plus 3 iota. Another complex number z2, which is iota plus 1. Other complex number is z3, which is negative iota. Other complex number is z4, which is 2 minus 5 by 3 iota. Another complex number is z5, which is equal to square root 2 plus 5 over 8 iota. Here we write some complex number. Now we take the conjugate of these complex number. How we take the conjugate of these complex number? We change the sign of the value of iota. The conjugate of z1 is z conjugate. We change the sign of the value of iota. Here the value of iota is 3 iota. Its sign is positive. After taking conjugate, its sign becomes negative. Therefore, sign of z1 conjugate becomes 2 minus 3 iota. In the second, z2 conjugate. In z2, if we change the sign of iota, here we see the first value is iota and the sign of iota is positive plus. Therefore, we change the sign of iota, it becomes negative, and 1 is same as that of positive. Now in the third example, z3 conjugate, here we see that iota contain the negative sign. Now we change the sign of iota, it becomes positive. Similarly, the fourth one, z4 conjugate is equal to 2 plus 5 by 3 iota. At last, z5 conjugate becomes square root 2 negative 5 by 8 iota. In the last, square root 2 becomes negative 5 by 8 iota. Therefore, if we take the conjugate of any complex number, in any complex number, if we change the sign of iota value, we get the conjugate of a complex number. Now on the next slide, we power of iota. We relate with the power of iota. As earlier I tell you that iota is equal to minus 1. Iota is equal to minus 1. As we know that by definition of a complex number. As we know that this iota is equal to square root minus 1. Now here we take the powers of iota and we get the different answer. First of all, if we squaring both sides, we have iota square, which is equal to minus 1. The next value, which is iota square, and this iota square is equal to minus 1. Clear? Iota is equal to square root minus 1 and iota square is equal to minus 1. Similarly, next, if we take cube, iota cube, then iota cube can be written as iota square into iota, because this iota contain power 1 and previous iota contain power 2. Bases are same. If we add the powers, we get iota cube. Now here we know that iota square is equal to negative 1 into iota, If we multiply by -1 into iota, we get negative iota. Therefore, iota cube becomes -1. Iota cube becomes -1. This iota cube becomes -1. Now similarly, here we solve the next power, iota 4. Iota 4, if we take iota 4, we can write iota 4 as iota square into square. We can write iota 4 as iota square into square. As we know that iota square is equal to -1 and square. If we take the square of a -1, we get +1. Therefore, iota 4 is equal to +1. Similarly, if we carry on this process, we get different values. That is, if we write iota 5, iota 5 is equal to iota, because it can be written as iota 4 into iota, and iota 4 is equal to 1 into iota, and it becomes only iota. That is, we can write iota 5 as iota. We can write iota 5 as iota. These are the powers of iota. Similarly, if we take the iota 6, iota 7, iota 8, and so on up to iota 99, iota 100, these are all the powers of iota. Now, we move on the next topic. Here are some properties, or note that here are some properties. First property, properties of complex number. What are the properties of complex number? First property, if we take the double conjugate of a complex number, then it's again come the same number, which is z. Similarly, the second property, conjugate of z is equal to z. Condition is if and only if z is a real number. If and only if z is a real number. If and only if z is a real number. What does the mean z is a real number? It means that z contain only the value of a real number. It doesn't contain the value of iota. It doesn't contain the value of iota. For example, here if we take z is equal to 2, or we can write it as 2 plus 0 iota, because iota value contains 0. 0 multiplied by iota is 0. There is only 2. Okay. Now, if we conjugate on both sides, take a conjugate on both sides, z conjugate in previous section. Abdul Ahad Kyani, what's the problem? Abdul Ahad Kyani,
सर
speak up. Yes, yes.
सर ये अयोटा पावर नहीं सर सही समझ आया.
ओके, मैं इसको दोबारा आपको थोड़ा सा डिटेल से बता देता हूँ. First of all, here z conjugate is equal to 2, and in previous we studied that conjugate of a real number is a self conjugate. Therefore, conjugate of 2 is 2, and 2 is equal to z. Therefore, if we have a real number, then its conjugate is same as that of a real number. In a previous slide, power of iota, as we know that by the definition of iota, this iota is equal to -1 with square root. That is, iota is equal to square root of -1. Ali Hussain.
सर मैंने कहना था प्लीज अगर आप ये फिर से समझा सकते हैं यही वाले एग्जांपल्स जो आपने लिखे हुए हैं.
मैं वही समझा रहा हूँ आपको, ये अगेन मैं रिपीट कर रहा हूँ. ये जो सारी मैंने एग्जांपल्स लिखी हैं ये मैं समझा रहा हूँ, ये रिपीट कर रहा हूँ. ओके. और अभी आपको जो भी मैं पढ़ाता जा रहा हूँ, if there is any problem, then at the end of the session we have 10 or 5 minutes, then resolve this. Okay. During lecture, please do not raise your hand. If there is any problem, then on LMS there is a recorded lesson. You repeat or see the recorded lesson on the LMS again and again in evening, in any time. Clear? Okay. Here we repeat the power of iota, as we know that the iota is equal to square root minus 1. First of all, आपको ये पता होना चाहिए this iota is equal to square root minus 1. Clear? Now, if we take the square on both sides, if we take the square, because we here relate about the power of iota. If we take the square on both sides, we get iota square and square root negative 1 square. Here iota square becomes iota square. After cancelling square root with square, we get negative 1, which means that iota square is always is equal to minus 1. Iota square is always is equal to minus 1. Now we come across the next cube. We come across the next power, which is cube. If we have iota cube, then iota cube can be written as we know that if we have a cube, how can we relate a cube? We can relate a cube as a square with a power 1. A square with a power 1. How can we relate iota cube? Iota cube is equal to iota square and iota power 1. In previous example, iota square is equal to negative 1. Instead of iota square, we write negative 1 and multiply it with iota. Then iota cube becomes negative iota. Iota cube becomes negative iota. Similarly, if we take the power 4 on iota, we have iota square square. Iota square and square becomes iota 4. What is iota square? Iota square is negative 1. Now we replace negative 1 instead of iota square. Now take the square of negative 1, we get positive 1. That is iota 4 is equal to positive 1. Similarly, iota 5, iota 6, and you resolve so many powers of iota. Clear? It's clear to everyone? Okay. Now we move on the next, we move on the page number 49. Page number 49. Exercise 2.5. On page number 49, exercise 2.5. The first question is evaluate. This is related to power of iota. Here we evaluate the power of iota. The first part is iota raised to power 7. Here we are find the value of iota raised to power 7. What is the value of iota raised to power 7? First of all, we write iota 7. First of all, we write iota 7. We can write iota 7 as iota 6 into iota 1, because iota 6 and iota 1 becomes iota 7. Now we split again iota 6 as iota square cube. Why? Because 2 multiplied by 3 becomes 6 and multiply it with iota. Clear? What is the value of iota square? The value of iota square is minus 1 and cube into iota. We know that if we have odd power, then negative sign remains. If we doesn't, if we have even power, then negative sign becomes positive sign. Here negative 1 cube becomes negative 1 into iota. If we multiply by negative 1 with iota, it becomes negative iota, which is the required answer. If there is any problem in this question, then raise your hand. If there is any problem in this question, then raise your hand. Yes. Atif Imtiaz. Akif.
सर ये अयोटा स्क्वायर जब हम अयोटा 6 को हम दोबारा सिंपलीफाई करेंगे अयोटा स्क्वायर और अयोटा क्यूब में, उसके बाद सर अयोटा स्क्वायर की वैल्यू तो -1 है, पर जो ऊपर 3 है सर ये खत्म हो जाएगा?
नहीं, खत्म नहीं होगा। अगर आपने छोटी क्लासेस में पढ़ा हुआ हो, if we have a cube of any number, for example a cube, we multiply a 3 times. Clear? If we have a cube of negative 1, we multiply negative 1 3 times. We multiply negative 1 3 times. Here we see that this negative and negative becomes positive, and then we relate this negative with this negative, it again becomes negative. It again becomes negative. Therefore, we have negative. Now, we multiply here 1 with 1 and again with 1. 1 multiplied by 1 becomes 1 and 1 again multiplied by 1 becomes positive 1. Clear? This
Yes,
negative
sir.
1, if we have odd power, then we have the negative sign in our answer. If we have an even power, then there is a positive sign. Therefore, Abdullah Hadkani.
Thank you, sir.